Okay, so we were on this last graph. What is it doing? Well, the slope is fairly large here and positive, but as time goes on, it gets more and more and more horizontal until it's perfectly horizontal. So the object is traveling in the positive direction, but slowing down until it stops. Then it turns around and begins to move in the opposite direction, speeding up at exactly the same rate, actually, as it was slowing down. So it's speeding up in the other direction. Okay? And so through it all, the acceleration is negative because it's moving in the positive direction, slowing down, moving in the negative direction, speeding up. What is an example of this? An example of this is throwing a ball up in the air, right? As I throw it up, I give it some velocity. It has a fairly big speed, but as it goes up, it slows down, it slows down, it slows down, it stops. And now it turns around, it comes back, speeding up, speeding up, speeding up at exactly the same rate. Okay, so that's the last graph. All right, a few more other little points. One, how does one find the distance traveled? So if you have a displacement versus time graph like this one, time in seconds, and displacement on this side, and I want to know how far did you travel in the first 4 seconds? Well, you just go to 4 seconds, you go up, you hit the line, you come over, and it's like, oh, you traveled 2 meters. Okay? If you were, like, how far did it travel? I think I was trying to probably aim for 7 there. In 7 seconds, again, you just go up, hit the point, read it off, 4 meters. How about how far did you travel in 10 seconds? So I was aiming for 10 here. So you'd say, okay, well, first you went up 2, and then another 2, that was 4, and then you came back 4, so that's 8, and then you went down another 2, so you traveled 10 meters in total. So you would just read them off the side of the graph. So distance traveled, read it off the side of the graph and add the pieces together. This is 0 because you're not moving. So add this piece, add this piece, add this piece, add this piece. Okay? Now, how do you get the displacement of an object? You still read it off the side of the graph. So we said this was 2. And if this was an east-west graph, then this would be 2 meters east. 0, this would be 2 meters east. This would be 4 meters west because of the slope, right? Negative slope. And this would be, and how do I know 4? Because you were at 4 and you came back to 0, reading it off the side of the graph. And this one, the slope is also negative, so you're traveling west 2 meters. So what's the displacement? This displacement should be where you end up. It should be 2 meters west. If I asked you what the displacement was at 5 seconds, you'd go up here, it would be 2 meters. Okay, so the displacement, you read it from the side of the graph and you keep the direction. So if you're down here, it's west. If you're up here, it's east. Whereas for distance, you have to add the pieces up. But remember, displacement is how far are you from where you started. Now that becomes important when you come to a question that asks you to find the average velocity or the average speed. So if we wanted to find the average velocity here, it'll be displacement over time, and my displacement was 2 meters west, and my time was 10 seconds. So my displacement is 0.2 meters per second west. But average speed, so this is with a vector, average speed is distance over time. And so the distance, when you add 2 and 2 and 4 and 2, that's 6, 8, 10. It's 10 meters over 10 seconds. The speed is 1 meter per second. And of course, this is the one that's closer to what you've done in real life. Okay? So now that we've finished that, I would like you to pause this video, and I would like you to try the front side of this sheet that I gave you today, the side that says displacement versus time. Okay, so turn me off, pause it. Don't turn me off, pause it so it comes back in the same spot. And try this graph if you didn't already, and then come back and we'll do it together. Okay, pausing. Good. All right, so you're back. So now let's take a look at these. Was the object ever stopped? So in a displacement versus time graph, stopped is when the slope is 0. So it's going to be stopped between 3 seconds and 5 seconds. It's going to be stopped between 10 seconds and 11 seconds. And it's going to be stopped between 19 seconds and 21 seconds. Oh, and over here, it's hard to tell if it continues, but if it continues out here, then it's stopped between 26 and 29 seconds. Okay, all the flat spots. What was the total distance traveled in 8 seconds? Well, it went 6 meters east, it stopped, it went 6 meters west. So distance, 6 plus 6, it should be 12. What's the total displacement after 8 seconds? Well, it went 6 meters east, it stopped, it went 6 meters west, it's back where it began. So the total displacement should be 0. What is the speed at the 2-second point? So whenever you see what is the speed or what is the velocity at a time, it wants you to find the slope, because the way we find the speed or velocity at a particular time is finding the slope. So what is the speed at the 2-second point? Well, you need to pick 2 points, and I would usually go with the endpoints. So this one is going to be 3 seconds and 6 meters. And this one's going to be 0 seconds and 0 meters. And so then you do, the slope is equal to y2, 6 meters, minus y1, 0 meters, over x2, 3 seconds, minus x1, 0 seconds. Oops, it's a second really. And so you get 2 meters per second. You don't need a direction because it's asking for speed. What is the speed at the 6-second point? So the 6-second point is on this line. So I would pick this point, which is 5 seconds and 6 meters. And I would pick this point, which is 8 seconds and 0 meters. And then I would do exactly the same thing. I might do it up here, just because I don't have room down there. So y2, 6 meters, minus y1, 0 meters, over x2, 6. Oh, so if you start with the 6, you have to start with the 5. You have to start with the same ordered pair. So 5 seconds minus 8 seconds. On the top, you get 6 meters. On the bottom, you get negative 3. So it becomes negative 2 meters per second, where the negative simply means it's going in the negative direction, which here would be west. So if we go back to our question, it's only asking what the speed is. Well, the speed is 2 meters per second. We don't put the direction in because it's not a vector. What is the velocity at 2 meters per second? Velocity, remember velocity is the slope and you keep the direction. So it should be the same answer as you got on question number 4, but this time with the direction. Question number 4, it worked out to be a positive 2 meters per second, so this will be 2 meters per second east. Question number 5 wanted the speed. Question at 6 seconds. Question number 7 wants the velocity at 6 seconds. So this time, remember that negative we ignored. We now put it in. It'll be 2 meters per second west. Okay, so whenever it says velocity, then you need to have a direction. Up here, this was 12 meters, and this was 0 meters. All right, what is the velocity at 13 seconds? So 13 seconds is over here. So again, I'd probably pick my endpoints. So this is 11 seconds and negative 8 meters. I think that's negative 8. Yeah. And I would pick this one, which is 15 seconds and 0 meters. And then do the same thing. So it's this guy. So it'll be y2, 0 meters, minus a minus 8, divided by 15 seconds minus 11. On the top, it's positive 8. On the bottom, 4. Lo and behold, we get 2 meters per second again. It works out to be positive. It's asking for velocity. This will be east. Okay, we're going to run